Hi guys, today we're going to be looking at A-level further mathematics, October-November 2023, paper 4-1. It's a further probability and statistics paper. So we'll start now. Question 1. Maya is an athlete who competes in 1,500-meter races. Last summer, her practice run times had mean 4.22 minutes. Over the winter, she has done some intense training to try to improve her times. A random sample of 10 of her practice run times, x minutes, this summer are summarized as follows. So this will be the number of samples that we have. We call it n. And this is the sum of her run times. This is the sum of the square of her run times. So the new run times are normally distributed, and she believes that on average her times have improved. Test at 5% significance level whether her belief is supported by the data. So she believes that her times have improved. That means our alternate hypothesis would be mean lesser than 4.22. Because it was 4.22 before the summer, right? So when the run times improve, it's for sure less than 4.22. So first step, we would write down the null hypothesis and the alternate hypothesis. So null hypothesis, we have mu equals to 4.22, and alternate hypothesis, we have mu less than 4.22. Second step, we need to find for the critical value. So we have p equals to 0.95 because it's a one-sided probability, 5 significance level, one-sided. So we have 0.95 as our p, and v would be the number of samples, 10 minus 1. So the degree of freedom will be 9. So now we can check the table, t distribution table. We have p as 9, p as 0.95, and v as 9. So we can see that the t value is 1.833. Alright? But we know that this is how the left side of the normal distribution the normal distribution graph looks like. This is how the left side looks like. And this would be the zero value. So everything before the zero value would be a negative number. And this would be negative t. So our t value would be negative 1.833 because it's the left hand side of the graph. Why is it left hand side? Because we want it to be less than the value. If it's more than the value, then it would be, we will need to consider the right side of the graph, and the t value would be a positive number. Alright, let's move on to step 3. We need to find for the test statistics. So the mean can be found by the sum divided by the number. So we have 42.05 divided by 10, and we would get 4.205. What about our s square value? S square value has the formula of 1 over n minus 1 times the sum of x squared minus the sum of x square the whole thing over n. So now we can plug in the values. We have 1 over 9 times sum of x squared is 176.83 minus 42.05 squared over 10. So now we have 13 over 12,000. Alright, and after getting x bar and s squared, we can now find for the t value, our test statistics. So t value, the formula is x bar minus mu over s squared over n square root the whole thing. So we plug in the figure, we have 4.205 minus 4.22 over 13 over 12,000 over 10. Then we square root the whole thing. So this would give us negative 1.44, rounded to 3 significant figure. In the fourth step, we compare test statistics and the critical value. So we know that negative 1.44 is larger than negative 1.833. Negative 1.833 is our critical value here. So we can sketch out the graph to see whether we have to accept or reject. Alright, this is the left side of the graph. Negative 1.833 is here. This would be the rejection region. And this would be the acceptance region. So negative 1.44 falls right here. And we can clearly see that our test statistics falls on the acceptance region. So we have to accept our null hypothesis, H naught. Finally, we can make our conclusion. Okay, our conclusion has to be related to the question and not just a general one. So we can first mention the significance level, and we mention if there's sufficient or insufficient evidence to conclude her belief that on average her times have improved. Okay, so we can write that at 5% significance level, there is insufficient evidence to conclude that the mean of Maya's new practice run times has improved. So this will be our conclusion, and we're done with question 1. Question 2. A town council has published its plans for redeveloping the town centre, and residents are being asked whether they approve or disapprove. A random sample of 250 responses have been selected from residents in the 4 main streets in the town: north, east, south, and west. Thus, at the 5% significance level, whether the opinions of residents are independent of the streets on where they live. So, same thing. Our first step would be the null and the alternative hypothesis. So the null hypothesis in the chi-square test is always that the opinions are independent of streets. Alright, it's always that the first variable is independent of the second variable. So we have opinions are independent of streets. And the alternative hypothesis would be opinions are not independent of streets. Okay, second step, we need to calculate the E value. So we can draw a table. So this is for north, this is for east, south, and west. Just follow the title here. So this will be approve and disapprove. At the last column, we will have the total, and the last row, we will also have the total. So now I'll divide each section into two parts. Okay, so at the top left corner, I would place the values from the table. I would put all these values in the top left corner, and the bottom right corner, I will leave it for the E value. So now I'll copy down the values: 42, 26, 19, 39, 28, and 9. And now I would sum up all these values and place it here, and this would give me 155. Same thing goes to this row. I would sum up all these values and put it here. So this would give me 95. And now I'll do it by column. So these two would give me 52. Second column would give me 93. Third column would give me 70. Last column, I would get 35. So the total here should be equal to the total here. And this would give 250, which is the total number of sample mentioned in the question. And now I will calculate the e-value. So e-value is the total number in the row times the total number in the column divided by the total number of samples. So let's say for this e-value, I would take 155 times 52 divided by 250. So I would get 32.24. And for this e-value, I would take 155 times 93 divided by 250. And this would give me 57.66. So same thing goes to here. 155 times 70 divided by 250, I would get 43.4, 21.7, 19.76, 35.34, 26.6, and 13.3. So these are all our e-values. And third step, we would need to find for the test statistics. So chi-square is equals to the sum of O minus E squared divided by E value. So we need to find O minus E squared divided by E for each of the box here. Alright, so we do it one by one. For this, we get 0.0179 plus, for this, we get 0.2323. For this, we get 0.0451 plus 0.852 plus 0.0292 plus 0.379 plus 0.0736 plus 1.3902. And we add all of this up to get 3.02 corrected to 3SF. So the fourth step would be finding the critical value. So P would be 1 minus 0.05, which is 0.95. And V would be 4 minus 1 times 2 minus 1. So the 4 here refers to the number of columns, and the 2 here refers to the number of rows. So this would give me 3. And now we refer to the formula booklet for chi-square distribution. So V is 3, and we find for 0.95, we would get 7.815. So the critical value would be 7.815. So fifth step, we compare the test statistics and the critical value. So since 3.02 is less than 7.815, when our test statistics is lesser than the critical value, we would accept H naught, which is our null hypothesis. If the test statistics is more than the critical value, we would reject H naught. Alright? So let's add another page. I'm running out of space. So the sixth step, which is our last step, we would have our conclusion. And our conclusion is, so we will need to refer to the question to mention the significance level and if there's insufficient or sufficient evidence to suggest their hypothesis. Alright, so we can write at 5% significant level, there is insufficient evidence, significance level. Okay, insufficient evidence to suggest that the opinion are not independent of 3 because we accept H naught, that means we reject H1. So there's insufficient evidence to accept H1. Okay? And we're done with question 2. Question 3. Scientists are studying the effects of exercise on LDL blood cholesterol levels. Over a 3-month period, a large group of people exercised for 20 minutes each day. For a randomly chosen sample of 10 of these people, the LDL blood cholesterol levels were measured at the beginning and at the end of the 3-month period. So we have 10 as our number of samples, and as we can see, for the same person, let's say for person A, they measure the cholesterol levels in the beginning and at the end. So we can know that these two set of data are dependent to each other because you cannot jumble up the data of two people and compare the cholesterol level, right? You have to compare it within the same person. So let's say for A, you can see that it decreases by 8 units, and for B, it decreases by 8 units as well, and so on. So this is a dependent sets of data. So for first step, same thing we would find for the null hypothesis and alternative hypothesis. So null hypothesis would be, oh sorry, I haven't read the question yet. So at 2.5% significance level, test whether there is evidence that the population mean LDL blood cholesterol level has reduced by more than 2 units after the 3-month period. So the null hypothesis would be the mean in the beginning minus the mean at the end equals to 2 units. And the alternative hypothesis would be the mean in the beginning minus the mean at the end is more than 2 units. Alright, so for part 2, we need to find for the critical value. And this is a one-tilt, this would be a one-tilt graph. Something like this, right? So our p-value would be 0.975 and our degree of freedom would be 10 minus 1, which is 9. So our t-value, let's look at the formula sheet. So the t-value would be 2.262. Alright, and now we can find for the test statistics. So we can let D equals to beginning minus N. So we can find the difference in the blood cholesterol level in 10 of these people here. Alright, so what we need to do is we take the beginning minus the N for each person. So for person A, the difference will be 8. Person B, also 8. Person C will be 15. Person D is negative 2. E would be negative 3. F is 20. G would be negative 3. H would be 0. I would be 5. And J would be 4. So we have found all the differences here. And now we can find for the sum of D and the sum of D squared. These two values are important because we will need to find for the mean of D, the mean of D and our S squared value. So for the sum of D, we can add all of this up and we would get 52 as our value. And the sum of D squared is we square all these values and we add everything up. So we would get 816. So now the mean of D would be just 52 divided by 10, which is 5.2. And S squared would be 1 over 9 times 816 minus 52 squared over 10. And this would give us 2728 over 45. So now we can find for our t value for our test statistics. So this would be 5.2 minus the mean value over here. Sorry, this one, which is 2 over our S squared value, which is 2728 over 45, divided by the number of samples, which is 10. And then we square the whole denominator. So we would get 1.30 as our test statistics. So fourth step, we need to compare the test statistics and our critical value. So we can see that our test statistics is 1.30 and the critical value is 2.262. And 1.30 is definitely less than this. So we can draw a graph, the normal distribution graph, and we can see that 2.262 is over here. This is the critical value, yeah? So this would be our rejection region. And this is our acceptance region. So 1.30 lies over here, and it falls under the acceptance region. So since 1.30 is less than 2.262, we accept H naught. Alright, and now we come to our conclusion. So conclusion, we need to mention our significance level. We need to mention if there's sufficient or insufficient evidence for the claim over here. So at 2.5% significance level, there is insufficient evidence that the population mean LDL blood cholesterol level has reduced by more than 2 units. And we're done with part A. Moving on to part B, state any assumption that you have made in part A. So in part A, we only have 10 samples and we decided to use the t-test. So in order to use the t-test, we would have assumed that the population is normally distributed. That's the assumption to use the t-test for a small value. So we can state in part B that the difference in LDL blood cholesterol level is normally distributed. Done. Question 4. As shown in the diagram, the continuous random variable x has probability density function f given by mx when x is between 0 and 2, and k over x squared plus t when x is between 2 and 6, and 0 otherwise. So part A, given that the probability of x less than or equals to 2 is 1 over 3, show that m is equals to 1/6 and find the values of k and c. So the first step, we need to find for the value of m. So we can integrate the PDF graph for mx. So we have 0 to 2, and we differentiate mx, we would get 1 over 3. So we would get mx squared over 2 equals to 1 over 3. sub the values in, we would have 4m over 2 minus 0 equals to 1 over 3, and m would be 1 over 6. So we have proven this, and now we need to find the values of k and c. So first off, we know that when x is equals to 2, f2 will have the same value no matter we use mx or k over x squared plus c. So we can sub x equals to 2 and 1 over 6 times 2 is equal to k over 2 squared plus c, because f2 has the same value. So this would be 1 over 3 and k over 4 plus c on the right side. So we can make c the subject. C would be equals to 1 over 3 minus k over 4. This would be our first equation. And this part is 1 over 3, and this part would definitely be 2 over 3, because the total probability is always 1. So the area under this whole graph here is 1. So we can integrate from 2 to 6, k over x squared plus c is equals to 2 over 3. So we integrate this, we can get negative k over x plus cx from 2 to 6 equals to 2 thirds. And we can sub the values in. We get k over 6 plus 6c plus k over 2 minus 2c is equal to 2 thirds. And we have k over 3 plus 4c equals to 2 thirds. This would be our second equation. So we sub the first equation into the second equation. We would get k over 3 plus 4 times c, which is 1 third minus k over 4 equals to 2 thirds. And this would give us negative 2 over 3k equals to negative 2 over 3. So k would be equals to 1. And now we find for the value of c. So c is 1 over 3 minus k over 4, which is 1 over 4. So we would get 1 over 12 as our value of c. Part B. Find the exact numerical value of the interquartile range of x. So for interquartile range, we will need our lower quartile and upper quartile. So we let L as our lower quartile and U as our upper quartile. So okay, so the graph is from 0 to 6 for the value of x, and this whole thing here, the total probability of this thing would be 1, And this would be our lower quartile and this would be our upper quartile. So this would be 1 over 4, 1 over 4, 1 over 4, and 1 over 4. That means from 0 to the lower quartile, the area under the graph would be 1 over 4. So we just need to integrate the graph of mx, which is 1 over 6x. We integrate it from 0 to the value of our lower quartile. So from 0 to L, we integrate the 1 over 6x graph to get 1 over 4. So this way we can find our lower quartile, which is, so we integrate this, we would get x squared over 12 equals to 1 over 4. So L squared over 12 equals to 1 over 4, and L squared would be 3, L would be 3. L cannot be a negative value because the x is just from 0 to 6. So for upper quartile, we can see that if we integrate the graph from the upper quartile to 6, we will also get 1 over 4. So we integrate it from u to 6, and the graph should be this graph. From the upper quartile to 6, we should integrate this graph to find the area here. Alright? So the graph would be k over x squared plus c, which is 1 over x squared plus 1 over 12. So integrating this, we will get negative 1 over x plus 1 over 12x equals to 1 over 4. Sub the values in, we get negative 1 over 6 plus 1 over 2 plus 1 over u minus u over 12 equals to 1 over 4. We simplify and rearrange the expressions. We would get u over 12 minus 1 over 12 minus 1 over u equals to 0. And we can multiply this whole equation by 12u to get u squared minus u minus 12 equals to 0. Factorize it, we have u minus 4 and u plus 3. So u would be equals to 4 and u will be equals to negative 3. But like what we said, u cannot be a negative value, so we have to reject this, and this would be the u that we want. So interquartile range is u minus L, which is 4 minus 3, and this would be the exact value. Question 5. The random variable x has the geometric distribution GeoP. Show that the probability generating function of x is pt over 1 minus qt, where q is 1 minus p. Okay, so the probability generating function, we call it gxt, is the sum of t to the power of x times the probability. And since it's a geometric function, our x value starts from 1 and it's infinity. Because we just keep doing it, we just keep trying until we get the result that we want. So this means that we have to start from x equals to 1 and we don't end the summation. So we have t to the power of 1 times the probability of x equals to 1 would be q0 times p. And when x equals to 2, we have t squared times q to the power of 1 times p. When x is 3, we have t to the power of 3 times q squared times p. When x is 4, we have t to the 4 times q to the 3 times p, and so on and so forth. So now we can factorize pt out, and we would have 1 plus qt plus qt squared plus qt cubed, and so on. So if you can see, this would be a geometric progression, the sum of the geometric progression to infinity, right? So sum of infinity, we have the formula as a over 1 minus r, right? So a would be 1 and r would be qt, since we times the value by qt, right? As you can see. So the final value would be pt over 1 minus qt. Part B. Use the probability generating function of x to show that variance of x is q over p squared. So variance of x has the formula of g prime 1 plus, g prime prime 1 plus g prime 1 minus the square of g prime 1. This means that we would need to find the value of g prime prime 1 and g prime 1. So we would first need to find for g prime t from gt. So gt is pt over 1 minus qt. So g prime t is just the differentiation of gt, which is 1 minus qt times p minus pt times negative q over 1 minus qt squared. So this will give us p minus pqt plus pqt over 1 minus qt squared. And this would be p over 1 minus qt squared. So g prime 1 would be p over 1 minus q squared, because we just sub t as 1. And now we can find for g prime prime t. So we differentiate this expression again. We would get negative 2p times 1 minus qt to the power of negative 3 times negative q. And this would give us 2pq times 1 minus qt to the power of negative 3. So g prime prime 1 is just 2pq times 1 minus q to the power of negative 3. And now we can find for variance. Let's move this over here. We're running out of space. Okay, for variance, it would be g prime prime 1 plus g prime 1 minus square of g prime 1, which is 2pq times 1 minus q to the power of negative 3 plus p over 1 minus q squared minus the square of p over 1 minus q squared. Let's write this as 2pq over 1 minus q cubed to make it easier when we simplify the fractions. So now we can make all this expression to have the same fraction, into the same fraction. So we would need to have the same denominator. So we can multiply the first fraction with 1 minus q. We multiply the second fraction by 1 minus q squared, and this would be p squared. So the denominator would be 1 minus q to the power of 4. And we can simplify the numerator. We have 2pq minus 2pq squared plus p minus 2pq plus q squared minus p squared over 1 minus q to the 4. So we can cancel off these two terms, and we have p minus p squared minus pq squared over 1 minus q to the 4. And we know that from part A, we know that q is 1 minus p. That means 1 minus q would give us p. So we can factorize the p out from the numerator. And would have 1 minus p minus q squared times p. And we would have p to the power of 4 in our denominator. So we can cancel this p out. One minus p minus q squared over pq. So now 1 minus p, we can also change it into q. So we have q minus q squared over 1 minus q cubed. We factorize the q out, we have 1 minus q and 1 minus q cubed. So we have q over 1 minus q squared. And the format they want would be q over p squared. So we have to change 1 minus q into p again. So q over p squared would be our final answer. Part C. Kenny throws an ordinary fair six-sided dice repeatedly, and the random variable x is the number of throws that Kenny takes in order to obtain a 6. The random variable z denotes the sum of two independent values of x. Find the probability generating function of x. Sorry, z. So now we first need to find the probability generating function of x using the information that they have given. So an ordinary fair six-sided dice. And to obtain a 6, the probability of success would be 1 over 6. So now we know the value of p, and q would be 5 over 6 because it's 1 minus 1 over 6, right? So our gxt would be 1 over 6t over 1 minus 5 over 6t. We sub the values of p and q in. We multiply by 6 on the numerator and the denominator. And now we would have t over 6 minus 5t. This would be the gxt function. And z is the sum of two independent values of x. So x plus x, right? That means gzt would be gxt times gxt, which is gxt squared. So t over 6 minus 5t squared would be the gzt function. Question 6. A school is conducting an experiment to see whether the distance that children can throw a ball increases in hot weather. In a cold day, they are asked to throw a ball, and the median distance thrown by a random sample of 25 of the children was 22.0 meters. So this would be the median during the cold day, and the children were asked to throw the ball again on a hot day by the same 25 children. So this would be the data of the 25 children on a hot day. There are 25 children in total. So the teacher claims that on average, the distances thrown will be further when it's hot. So the teacher believes that the distance would be more than 22.0 meters when it's hot. Carry out a Wilcoxon sign rank test at 5% significance level to test whether the data supports the teacher's claim. So Wilcoxon sign rank test we would use the median of the sample instead of the mean. Alright? So same thing. First step, find out the null hypothesis and alternative hypothesis. Null hypothesis will be median equals to 22.0, and alternative hypothesis would be median is more than 22.0. Okay, second step, because the sample size is 25, which is larger than 20. So in this case, we cannot use this table over here, Wilcoxon sign rank test. We can see that the sample size is only until 20, so we can't really use this table. Instead, they have mentioned that for larger values of n, we need to approximate it to the normal distribution to find for the data over here, to find for the test statistics. So we need to approximate the mean value and the variance using these formulas here. So the mean value would be 1 over 4 times n, which is 25, times n plus 1, which is 26. So this would give us 162.5. And our variance would be 1 over 24 times n, which is 25, times n plus 1, which is 26, times 2 times n plus 1. So this would be 1381.25. Okay, now for the test statistics. We first need to find the difference between these values and the mean during the cold day. So we take the values one by one minus 22.0. We can draw a table. 3, 4, 5. So I would use different colors to differentiate the values. So for the differences, I would use black, and for the ranking, I would use blue. So now we can start finding the differences. We take 21.2 minus 22, which is negative 0.8, and 22.1 minus 22 would be 0.1, so on and so forth. So I'll just write it down. So we would now rank the differences regardless of the sign. But if it's a negative value, we would add a negative sign to the ranking as well. So I'll show you what I mean by that. So 0.1 would be our the first difference, the smallest difference. The second one would be 0.2. Third one, 0.3. Fourth would be negative 0.5. And since it's a negative value, we would add a negative in front of our 4. So 5 would be 0.6. 6 would be 0.7. 7 would be 0.8. 8 would be 0.9, 9 would be 1.0, 10 would be 1.3, 11 would be negative 1.4, 12 would be 1.5, 13 would be 1.7, 14 would be negative 1.8, 15 would be 1.9, 16 negative 2.2, 17 would be 2.3, 18 would be negative 2.6, 19 would be negative 3.4, 20 would be 3.7, 21 would be 4.5, negative 4.6 would be 22, 5 would be 23, 5.2 will be 24, and lastly 6.2 will be the 25th one. So now we can start finding for the p-value and our q-value. So for p-value is the sum of the positive ranks, and the q-value would be the sum of the negative ranks, all the negative ranks. Alright, so our p-value would be 214 and q-value would be 111, and our test statistics, the t-value, would be the smaller of p and q. So q in this case would be smaller, so t would be 111. Okay, and now we need to find the probability that t is smaller than and equals to 111. Smaller than or equals to 111, and we will need to do a correction to this value over here because we are changing it to a normal distribution, right? Remember this? We are changing it into a normal distribution, so we need to do a continuity correction. So t less than equals to 111, that means the values would be 0 to 111, right? And to do this, to do the correction, we just have to add a 0.5 to the last value that we are considering. So we have the probability of t less than 111.5. So we can start finding for the z value. Z would be 111.5 minus the mean, which is 162.5, divided by the square root of variance, 1381.25, square root that. This would give us negative 1.372. And for a normal distribution graph, it's symmetrical. So if negative 1.372 is here, positive 1.372 will be here, and the probability that z is lesser than negative 1.372 here, this area here, and this area here will be equal. So this is also equals to 1 minus the probability that z is less than 1.372. This value would be the area over here. So 1 minus this area would be the area over here, which is equals to this. So referring to the formula booklet, one point three seven two would be 0.915. So this would be 0.085, and from the question we know that they want the significance level to be 5%, which means 0.05 is over here. The area 0.05 is over here, and the area 0.085 is over here. And we can see that 0.05 is the rejection region, and the test statistics clearly didn't fall into the rejection region, right? It's still in the acceptance region over here. That means we would need to accept H0. So 0.085 is larger than 0.05, so we accept H0. So our conclusion would be, at 5% significance level, there is insufficient evidence to support the teacher's claim. And we're done.